Hello everyone, welcome back to the chemistry series. Today we're going to be going over balancing chemical equations in chemistry episode number 8. Now there's some vocabulary you're going to need to know when balancing chemical equations. So one vocabulary term is the reactants, right? Oh, yeah. The the reactants. Spoiler, but the reactants are the molecules or substances on the left-hand side of an equation. Now, a chemical equation is like a math equation, right? There's the left-hand side and the right-hand side. Now, the substances on the left-hand side are the reactants. The substances on the right-hand side are called the products, though. And through this reaction represented by this arrow, you can also say that this arrow is when talking about a chemical equation, you can say this arrow by just saying yields. So through the reaction, the reactants that you start with turn into the products that you end with. A chemical reaction just turns a substance or multiple substances into another substance or another multiple substances, right? So the reactants turn into the products through the reaction. Now, there's also subscripts. So subscripts are this number on the bottom right side of an element in an equation, right? And subscripts tell us how many of an element is in a molecule. So molecules are separated by these plus signs, right? So this would be one molecule. Now, if you can all remember, H is the chemical symbol or element symbol for hydrogen, right? And so this too is telling us that there are two hydrogen atoms in this whole molecule, and this molecule is called hydrogen gas. So it's telling us that there's two hydrogen atoms in this molecule, and the same with this one, right? O is the chemical or the element symbol for oxygen. So this 2 is telling us that there are two oxygen atoms in this molecule. There's also coefficients, which is telling us how many molecules are on each side of the equation, right? So this 2, if there was a 2 here, that means there'd be two hydrogen gas molecules. But there's not a 2 here. I'm just giving that as an example. I mean, at least not yet. But when we balance the chemical equation, we're going to do it by adding these coefficients because this equation is not balanced yet. Now, what does it mean for an equation to be balanced? Well, the law of conservation of a mass, this is a law of the universe, and it means that mass cannot be created nor destroyed, right? It means that mass cannot be created nor destroyed. So that means that the number of atoms of an element on the reactant side needs to be the same of the number of atoms of those same elements on the product side. So basically this side and this side needs to be equal, just like in a math equation, right? If both sides aren't equal, then the equation is false. So to make them equal, we can balance chemical equations, right? And so how do we balance chemical equations? Well, first you count the number of atoms of each element on each side. So on the left-hand side, or the reactant side, using our new vocabulary, we can see that there's two hydrogen atoms, right? Because the coefficient is 1, because if you don't see anything on the coefficient or subscript where they would usually be, if you don't see anything, you can just assume that it's a 1. So like here, this O, that means just 1, and there's no coefficient here, so you can just assume 1. So there's one molecule of H2, and in H2 there's two hydrogen atoms. So you just multiply those, so you have two hydrogen atoms on the left side, at least right now. And then here, same scenario, right? The coefficient is 1. 1 times 2 oxygen atoms in this molecule, an oxygen gas molecule. That means there's 2 oxygen atoms on the left-hand side, or the reactant side. Now on the product side, we can count the number of hydrogen atoms. That would be 2. Again, there's no coefficients yet because we're yet to balance the equation. So there's 2 hydrogen atoms, and there's no subscript for this oxygen, so that we can just assume that there's 1 oxygen in this molecule, which this is just a water molecule. And since there are no coefficients, then we can just assume that it's 1, right? Now, we've counted the number of atoms of each element on both sides. Now, let's see if it's equal. Well, there are 2 hydrogen atoms on the left-hand side and 2 hydrogen atoms on the right-hand side. Sure, that's equal. But now there's 2 oxygen atoms on the left-hand side and 1 oxygen atom on the right-hand side. That's not equal, right? So what we can do is now add coefficients to make this equation balanced. Now, we can't add like 1/2 of a coefficient to make this number smaller, so we would have to make this number bigger on the right-hand side, and we can do that by adding a coefficient. Now, 1 times what would equal 2, right? Because we want 2 oxygen atoms, as there's 2 oxygen atoms on this side as well, and that would obviously be 2, right? So you would add the coefficient of 2 here. So now this 1 gets multiplied by 2, and now there's 2 oxygen atoms on the right-hand side. But remember, there's also hydrogen here. So the hydrogen, these 2 hydrogen atoms get multiplied by 2, and now you have 4 hydrogen atoms. Well, now the number of oxygen atoms is balanced, right? They're both 2, but the number of hydrogen atoms on both sides, on the left-hand side is 2 hydrogen atoms, on the right-hand side is 4 hydrogen atoms, so it's still not balanced. Well, now we go on to the left-hand side. It's the lesser side. So now let's add a coefficient to the molecule that has hydrogen in it, which is obviously this one. So let's add a coefficient of 2, since 2 times 2 equals 4, right? Obviously, right? And now we have 2 times 2. It would be 4. And so now there's 4 hydrogen atoms on the left-hand side, 4 hydrogen atoms on the right-hand side, and 2 oxygen atoms on the left-hand side, and 2 oxygen atoms on the right-hand side. So now this equation is balanced. So you can now confidently say that 2 hydrogen gas molecules plus 1 oxygen gas molecule will yield 2 water molecules. And that is how to balance chemical equations. So I've drawn a chemical equation here, and see if you can pause the video right now and solve this. So take a few minutes, see if you can solve the equation below, pause the video right now, see if you can solve it. Okay, I'll reveal the answer now. So first, you start with counting the number of atoms on each side. I mean, if you're good enough at it, I mean, you don't have to do it, but I mean, if you're just starting out, it's useful to practice so that you can get better. So there's 2 nitrogen atoms since there's no coefficient starting out. So you can just assume that this coefficient is 1, so 1 times 2, 2 nitrogen atoms. And now, again, 1 hydrogen gas molecule, there's 2 hydrogen atoms, so 1 times 2, that would be 2. Now, on the right-hand side, there would be 1 nitrogen atom and 3 hydrogen atoms. Again, there's no coefficient. We can assume that it's 1. And there's no subscript for nitrogen, so we can also assume that it's 1. So 1 times 1, 1. And then 1 times 3, that would be 3, right? And so now we've counted up all the atoms. So we can just start with nitrogen here. So there's only one nitrogen atom on this side, but there's two on this side. So since this is the lesser side, we'll just start over here on the product side. So we can change the coefficient to 2, since 1 times 2 is 2. And now this would be 2 nitrogen atoms. You can't forget about hydrogen. That's also in this ammonia molecule. This is called ammonia molecule. And so you would also do 2 times 3, and you would get 6 hydrogen atoms. But now we have 6 hydrogen atoms on the product side and only 2 on the reactant side. So you have to also balance the reactant side. So now you can add 3 to this hydrogen gas molecule, since 3 times 2 would be 6. So now you have 6 hydrogen atoms on the reactant side and 6 on the product side. So now we are all good. This equation is balanced, right? There's 2 nitrogen atoms on the reactant side, 2 on the product side, and 6 hydrogen atoms on the reactant side, 6 on the product side. So good job if you got it right, and it's fine if you still didn't get it. Of course, we're just practicing now, but I hope you feel confident with balancing chemical equations after this video, and I'll see you next time.